Welcome to the Explainer. You know, right now, inside every single one of your cells, there's a communication network buzzing with activity. It's like a high-speed messaging system, and it's basically deciding your health from one moment to the next. It's called redox signaling.
So, let's just jump right in by tackling something you've probably heard a million times. For years, we've been told that free radicals are the bad guys, right? These rogue molecules that are just out to make us age and get sick. But what if that's only half the story? What if your body actually needs them to survive?
You see, we used to think of these molecules, which are technically called reactive oxygen species, as just, well, toxic junk left over from breathing. But now we know they're a huge part of a vital messaging system. So think of them less like cellular exhaust and more like the emails, the DMs, and the emergency alerts that keep your cells working the way they're supposed to.
So how in the world does this cellular internet actually work? How does it send and receive messages? Well, it's a really elegant process that all boils down to some basic chemistry, and it all starts with a simple little handoff.
The whole system is built on this principle called redox. It sounds kind of complicated, but it's just a mashup of the words reduction and oxidation. All it really means is that electrons are being passed from one molecule to another. Seriously, just imagine a tiny biological baton race happening trillions of times a second inside of you. That's it. And the result of that little electron transfer? It's absolutely huge. By either gaining or losing an electron, a protein can completely change its shape and its job. This simple act is like an on-off switch for countless critical processes in your body. Everything from generating energy to repairing your DNA.
And so who are the actual messengers carrying these signals? Well, they're the very molecules we used to think of as the villains. Superoxide often kicks the whole thing off, but it's the more stable hydrogen peroxide that actually travels to deliver the message. And then you've got specialists like nitric oxide, which is just crucial for things like regulating your blood pressure.
The whole process is incredibly efficient. First, a signal like superoxide gets generated, usually by our cellular power plants, the mitochondria. Then it gets converted into a more stable messenger like hydrogen peroxide, which cruises over to a specific target protein. And finally, boom! It delivers its message, flips that protein switch, and makes something happen.
But wait a second. These messenger molecules are, highly reactive by nature. They're like tiny little sparks. So how does the body use this fire to send signals without, burning the whole house down? Well, it all comes down to control.
And this brings us to a really critical point. The goal isn't to just eliminate these molecules. We literally can't live without them. The goal is homeostasis, a perfect state of balance. Your body wants just the right amount of signal sent to the right place at exactly the right time.
To keep that balance, our cells have this amazing built-in control system. We have what you can think of as enzymatic fire extinguishers, things like SOD and catalase. These are proteins that work at lightning speed to neutralize the signal as soon as the message is delivered. And then there's the master antioxidant, glutathione, which acts like a giant shock absorber for the whole cell, just keeping the entire environment stable.
And all of this just goes to show how incredibly important that control system is. Because when that delicate balance is lost, when the signals get way too loud or the controls just can't keep up, the consequences are pretty serious. When the system loses control, it's kind of like a fire alarm that just won't shut off. Those signals that are supposed to be temporary and targeted become constant and widespread. The cell's whole communication network just spirals into chaos. And this chaotic state, it has a name you've probably heard before. Oxidative stress. This is exactly what happens when the production of these reactive signal molecules just completely overwhelms the body's ability to clean them up. It's the too much all the time scenario.
And this is why this all matters so much. This state of imbalance, of this out-of-control signaling, it isn't just some abstract problem. It is a fundamental driver behind so many of our biggest health challenges, from the aging process itself to chronic inflammation and even the development of diseases like cancer.
So this brings us to what might be the single most important takeaway from all of this. The key point isn't that these molecules are good or bad. It's that their role is completely dependent on context and, you guessed it, balance. This idea of a delicate dance, I think, just perfectly captures what's going on. Your body is constantly, every second, using these reactive molecules to give life-sustaining direction to your cells, while at the very same time preventing them from causing destructive damage. It's not a war we need to win. It's a balance we need to maintain.
Understanding this dance completely changes how we should think about health. The goal isn't just to fight free radicals with antioxidants. The real question is so much deeper. It's how can we support our bodies in this delicate, life-giving performance? And how can we make sure that the dance between damage and direction stays perfectly, beautifully in balance?